Alrighty, welcome to lesson 2-2, which is all about proving that lines are parallel. In lesson 2-1, we were given that lines were parallel and we were proving that angles were congruent. And now we're kind of going the opposite way, right? So we're trying to prove, are the lines parallel? So by the end of this lesson, we're going to be able to use angle relationships to prove that lines are parallel. And we're going to introduce a new type of proof today, and it's called a flow proof. And so we'll talk about what that is. And then we have a bunch of theorems and postulates today. And they're all just the converse of the ones that we've already talked about, meaning it's just going the opposite direction. So let's scroll to the end, let's go to the end of our notebook, or end of our note catcher here, where all of the terms and theorems are and things like that. And let's go ahead and fill out all of our vocabulary and our theorems. So on your terms page, it should be down towards the bottom. We're looking for where it says flow proof. This is going to be our only term for the day. And this is a proof using circles or boxes connected with arrows and descriptions. So we tend to use like these ovals. So you can have ovals and then arrows connecting and maybe another oval, right? And so the thing to remember is that in this type of proof, your statement goes inside the bubble and then your reason goes right underneath the bubble. So as we go down, right, we are connecting things in a flow proof. So we're going to have a bubble with a statement and a reason, and then that leads us into something else. And so we're going to do, quite a few examples of this today. And so hopefully the more that we practice it, the more that it'll make sense, okay? However, we do have quite a few of postulates and theorems and formulas. So let's go to that page. And we're starting here with the converse of corresponding angles theorem. So again, sorry that the writing is not in there. I'm not sure what happened. But the converse is in parallel lines. So, sorry. No, scratch that, right? If corresponding angles are congruent, then lines are parallel. So this is going the opposite way. So the corresponding angles theorem said that if lines are parallel, then corresponding angles are equal. Here we're going, if corresponding angles are equal, then the lines are parallel. So we're just going the opposite direction in that. So if I go to like draw an example, say here's a line, let's call that line L, and let's call this one line M, and if I have a transversal, and let's call this angle 1, and let's call this angle 2. Okay, so if the measure of angle 1 equals the measure of angle 2, then L is parallel to M. So you're just going the opposite way. Instead of given that the lines are parallel, you're given that the angles are equal. Okay, let's move on. Let's look at the converse of alternate interior angles. Okay, so it's going to be the same thing. If alternate interior angles are congruent, then lines are parallel. Okay, so if alternate interior angles are congruent, then lines are parallel. So if I draw two lines again with some sort of transversal, okay, here's angle 1, here's angle 2. They are alternate interior angles because they're on opposite sides of the transversal, and they're both inside. So this is just saying if I know that the measure of angle 1 equals the measure of angle 2, then I can automatically say, oops, I should label this again, L and M. Then I can say that line L is parallel to line M. Okay, so if I know that those angles are the same, then I can go ahead and say that the lines are parallel. And this trend just kind of continues on, okay? So so this is the converse of same side interior. If same side interior angles I should say are supplementary, are supplementary, so not congruent, right? Because we're talking about same side interior. So, but if they are supplementary, then the lines are parallel. My pen is real jumpy. I'm having a hard time following. Sorry. So if same side interior angles are supplementary, then the lines are parallel. So here's one line. Here's another line. Here's my transversal. So this is angle 1, and this is angle 2. So this is just saying if the measure of angle 1 plus the measure of angle 2 equals 180. So if I know that that's true, then I can say, and I forgot to label them again, L, M, then line L is parallel to line M. The last one, same thing. If alternate exterior angles are congruent, then lines are parallel. Same idea. There's two lines, right? Line L, line M, the line coming through. Okay, so this is angle 1, and this is angle 2. Those are alternate exterior angles. So this tells me if the measure of angle 1 equals the measure of angle 2, then I can say that L is parallel to M. So hopefully that's kind of making sense here. And we have a couple more. I'm going to go ahead and clear this, and let's scroll down because we have a couple more to look at here. Theorem 2-8 and theorem 2-9. Okay, 2-8 says if two lines are parallel to the same line, then they are parallel to each other. So we're going to look at this and see what this means, okay? So I'm going to draw 3 lines. And then I'm going to switch up the colors so that we can kind of look at this differently. Okay, so I'm going to call this A, this line B, and this line C. Okay, let's get a different color going. Okay, so if I have 2 lines that are parallel to the same line, so let's say that C is parallel to B. Okay, so C and B are parallel. So I'm going to say if B is parallel to C, right? And so then let's also say that A is parallel to C. So now I'm going to draw this. And A is parallel to C. So B is parallel to C and A is parallel to C. Okay, so if that happens, then that means that A is parallel to B. Okay, so B and C are parallel and A and C are parallel. That means that C is parallel to both B and A, which means A and B also have to be parallel. So that's what where that one comes from. The next one that we're going to look at is theorem 2-9. So this says if 2 lines are, and I'm going to use the symbol, right, perpendicular. So remember that means perpendicular. So if 2 lines are perpendicular to the same line, then they are parallel to each other. So if 2 lines are perpendicular to the same line, then they are parallel to each other. So let's think of this. If I have a line, and that line is perpendicular to this line, let's just say, and I'm going to call this B and this C. So if this is perpendicular, but then I also have line A, and A is also perpendicular. Okay, so if A and B are both perpendicular, so if A is perpendicular to C and B is perpendicular to C, they're both 90. Well, let's look here. If this is 90 and this is 90, those are corresponding angles. They're in the same position. So if corresponding angles are the same, then I know that these lines are parallel. Okay, so if A is perpendicular to C and B is perpendicular to C, then A is parallel to B. And I think that is it for our theorems and whatnot for today. So we're going to clear this out and we're going to practice some flow proofs and just mostly flow proofs today. And then just some basic solving the other way, right? So I'm given that angles are the same. Can I prove that lines are parallel? So we're going to go back to section 2.2 so that we can take notes. All right, so let's actually look at our notes now for 2-2, proving lines parallel. And we're going to just start right off the bat with some flow charts just to kind of show you how those work. Okay, so first example here says write a flow proof. It said flow chart. It's the same thing. Okay. I just grew up learning flow chart instead of flow proof, so I will probably say that more than once. Write a flow proof to prove the converse of alternate interior angles theorem. So here I'm given that angle 1 and angle 2 are congruent, and it's already drawn in here for me, so that's nice. Okay. And I'm trying to prove that line L is parallel to line M. Okay, so again, I'm going to start with what I'm given. So I'm going to draw a bubble here, and I'm given that angle 1 is congruent to angle 2. So my statement goes inside, and then my reason goes outside. So that's given. Okay, so that's one thing that I know. Another thing that I notice as I look at this is that angle 1 is congruent to angle 3, right? Because they're across from each other, and those are called our vertical angles. So hopefully we remember that from last topic, so vertical angles. So if 1 is 2 and 1 is 3, then can I say that 2 and 3 are the same, right? If 2 equals 1 and 3 equals 1, then they're the same thing. So with this information, I can take both of those pieces of information and put them together and say that angle 1 is congruent to angle 3. And that's just the transitive property. Or you can use substitution. That I would be okay with that as well. Okay, but if one of them is angle 3 and the other one's angle 3, then they're the same. Or sorry, angle 1, not angle 3. Well, okay, so now I know, oh sorry, I put 1 and 3. I meant 2 and 3. This is why I need you guys in class to yell at me, right? Miss G, you wrote it down wrong. There we go, 2 and 3. Okay, so I'm looking here. If 2 and 3 are the same, then I know that line L and M are parallel because there's a property for that. So I can say that L is parallel to M because of the converse of corresponding angles. Lots of writing on this one. Corresponding angles. Right? The converse of corresponding angles says that if corresponding angles are equal, which in this case corresponding angles are 2 and 3, if they're equal, which we show that they are, then the lines are parallel. Okay? So if the lines are equal, or if the angles are equal, then the lines are parallel. So this is an example of a flowchart or flow proof. Okay, you're just using these bubbles, and inside the bubble is your statement, and then outside the bubble is your reason. Okay, so let's look at another one here. And this one, I'm just going to go ahead and apologize. It's missing information, so we're going to have to write in our own information here. Because it doesn't tell me what I'm given or anything like that, right? And I apologize. So in this problem, I'm given that angle 1 and angle 2 are supplementary. And I want to prove that L is parallel to M. And I'm also going to need an angle 3 here. So Okay, so this one has a little bit more going on with it. Okay, so the first thing that I know, and I'm going to go ahead and erase this because I'm going to need this space. Okay, but just know it's still there. And I still want that 3 there. Okay, so I can start with what I'm given. I'm probably going to need a bigger bubble than that to write everything. Let's see if I can make this bigger so I can write more. There we go. That's what I want. Okay. Okay. So the first thing I was given that angle 1 and angle 2 are supplementary. Okay, and this was given. I was told that. Since they're supplementary, what does supplementary mean, right? Well, it means that angle 1 plus angle 2 equals 180. And that is the definition of supplementary. Right, by definition of supplementary, 1 plus 2 equals 180. I'm also noticing here that angle 2 plus angle 3 equals 180 because those are a linear pair. So hopefully that makes sense, right? 2 and 3 also add to 180. So if 1 and 2 add to 180 and 2 and 3 add to 180, then I can say that those are equal. So angle 1 plus angle 2 equals angle 2 plus angle 3. And we can use transitive property or we can use substitution. So again, either way. If I subtract my angle 2 from both sides, I just get that angle 1 is congruent to angle 3. And that's just from subtraction. All I did was subtract angle 2 to both sides. I have to draw my last one here. Okay. Now, if angle 1 and angle 3 are the same, they're corresponding. Okay, so if corresponding angles are the same, then these lines are parallel. So I can say that L is parallel to M by the converse of corresponding angles. Corresponding angles. Okay, so what we're saying is, hey, these two angles are equal, therefore the lines are parallel. So I'm just going the opposite way. And we have one more that we're going to look at. Hopefully these are making sense. Again, please reach out if you need help on any of these, okay, whether it's a proof or not. Okay, so the last one is I'm given that M and N are parallel. So that's good. And I want to write a proof to show that 1 and 2 are equal. Okay, so right, we always start with what we're given. So M is parallel to N. That's given. Then I'm going to write down anything else that I know. So I know that angle 2 plus angle 3 equal 180, right? Because they're a linear pair. And I know that angle 1 plus angle 3 equals 180 because those are same side interior. Same side interior. Okay. So if 2 and 3 are 180 and 1 and 3 are 180, I can take this information and plug it in and say angle 2 plus angle 3 equals angle 1 plus angle 3. Oh my gosh, and these should all have measures. I'm just like not in it right now. So the measure, measure. I'm so sorry. Okay. And this is transitive property or substitution. I know I've been going back and forth on this. I just want to show you that you can do either. Okay. So transitive property. If I subtract the measure of angle 3 from both sides, I get that the measure of angle 2 is equal to the measure of angle 1 by substitution. Sorry, not substitution, subtraction. Right, I subtracted angle 3 from both sides. And that's what I was trying to prove. I'm trying to prove that measure of angle 1 is equal to measure of angle 2, and I've done that. So that's it. I'm done with that flow proof. So again, could you use a 2-column proof here? Absolutely. It specifically asked me to find whether the measure of angle 1 is equal to the measure of angle 2, and it specifically asked me to use a flow proof. But if it didn't ask, if it just asked me to prove it, I could use a 2-column proof just as easily. Okay, so let's move on to example 3, and we're almost done. Okay, so example 2 here says the edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edges of the sidewalk are parallel? So let's start by just simplifying this drawing, right? There's a lot of stuff going on. So let's just draw the sidewalk, right? So here's the sidewalk. And then I have a street coming through, more or less, and this is labeled as 53. This is labeled as 1, and then here's another street. This is labeled as 2. Oh, and this is also labeled as 53. Okay, so how does an inspector know that the edges of the sidewalk are straight, right? How do we know that the edges of the sidewalk are parallel? Well, if I look here, I have alternate exterior angles. So even if I just take off all of this right here and just look here, I have alternate exterior angles. So 53 is on the outside, 53 is on the outside, and they're on opposite sides of the parallel lines. So how does the inspector know that the sidewalks are parallel? So we can say alternate exterior angles are congruent so the sidewalk is parallel. Because alternate exterior angles are the same, we can go ahead and say that the sidewalk is parallel. Then for our try it says, what is the measure of angle 1? So what is the measure of angle 1? And what should angle 2 measure in order to guarantee that the sidewalk is parallel to Main Street? So I want you guys to go ahead and hit pause on this video and try this. Find the measure of angle 1 and find what angle 2 should be in order for the sidewalk to be parallel to the street. Okay, so if we drew this again, right here I have my sidewalk. This is 53. This is angle 1. This is 53. And here's angle 2. Okay, so I see that angle 1 and 53 are a linear pair. because they add to 180. So the measure of angle 1 is 180 minus 53, which is 127. Okay, and then it's asking me what would the angle of measure 2 have to be in order for the sidewalk to be parallel to the street. And in order for that to happen, my same side interior angles would have to be 180, right? Because they add to 180. So 180 minus 127, and I get, oops, not 1. I get 53. So the measure angle 2 would also have to be 53. Or you could use alternate interior angles. So alternate interior, you could use, or you could use same side interior. Either one of those would probably make the most sense here. Whatever helps you think about it is fine. Okay, but if measure of angle 2, right here, if this is 53, then I am guaranteed that the sidewalk and the street are parallel to each other. Okay, so we have one example left, so let's go ahead and look at that. In example 3, and we're solving a problem with parallel lines. So this says when building a gate, so here's my gate, how does Bailey know that the vertical boards V, so right here, and W are parallel? How does she know that those are parallel? Okay, and so the real answer here, right, is I know that this is perpendicular to the bottom. If I draw a line here on the base, I know that these two are perpendicular. So we have to think back to those theorems that we looked at earlier in the video, right? If I have two lines and they are perpendicular to the same line, then those two lines are parallel. Okay, so we can just write that. So two lines perpendicular to the same line So two lines. So line V is perpendicular to the base and line W is perpendicular to the base. So I have two lines that are perpendicular to the same line. So those lines are parallel. So that tells me that V is parallel to W. Okay, so there's that. Let's get rid of this so we can kind of simplify it a little bit. There we go. Part B says, what should angle 1 measure? It's right here. To ensure that board B, right here, is parallel to board A. So if I draw this separately, just to kind of help us visualize, here's B, here's A, and I have this weird board going through, and this one is 35, and I want to know what is this have to be. Okay, if A and B are parallel, then I know that these two angles add to 180, right? They're same side interior. So same side interior. So that tells me that the angle 1 plus 35 equals 180. Okay, if I subtract 35 to both sides, I get that the measure of angle 1 is equal to 145. So if angle 1 is 145, then I can say for a fact that A and B are parallel to each other. Okay. And then let's look at our last two. This might be kind of hard for me to fit the picture and the question together, but we'll do the best we can, okay? Bailey also needs board C, right there, to be parallel to board A. What should measure 2 equal? Okay, so measure 2 is right here. And here's 1. And I know that A and V are 90 degrees. Right, so same side interior has to add to 180. So 180 minus 90 is 90. So in order for that to be true, that would have to be 90. So the measure of angle 2 has to be 90 degrees. And there's a couple different ways that we can look here, but I would use the converse of same side interior angles. So that says if the angles add to 180, then board A and board C are parallel. That's clear. So read this. Okay. And then the last question is B parallel to C. So the question is, and I'm going to have to move it down so we don't see it, but is B parallel to C? So that's what we're looking at. So let's scroll down and actually look at the this is really hard because I need the image too, right? Okay, there we go. Okay, so is B parallel to C? So let's look. I know that V and W are perpendicular, right, to A. Do I know anything about this line B? Okay, I know that if angle 1 is 145, then these lines are parallel, but I'm not told that angle 1 is 145. Same thing with 3, same thing with 2. I'm not told what those angles are. So I actually have no way to find out if B and C, or sorry, if, well, I'm up here, B and C. I have no way to figure out if these two lines are parallel to each other. Okay. If I knew that B was parallel to A and C was parallel to A, then I could say yes. But that information is not given to me. So this is just not enough information to determine. I would need more information in order to make the decision on whether or not B is parallel to C. So not enough information to determine. Okay, so that's actually it for section 2.2. It's a pretty short section. As always, if you guys need help, make sure you reach out to one of your teachers. And if there's any questions or follow-ups or anything that we can do, just let us know. And we'll see you next time.